So for problem 2-24, we are going to be using the Chem-Me equation of in minus out plus generation equals accumulation. As we can see here, this is the flux times area. In, out, generation is equal to delta E over delta T is equal to Q in minus Q out plus E gen volume. We can then begin to plug in as E in and E out are equal to flux times area. Here we can then use Fourier's law and plug in the values associated, and then take the limit as our differential radius delta R goes to 0. Therefore, we can determine this general conduction equation. For 2-66, we can use the simplification of the general equation because it is steady state, one-dimensional, constant thermal conductivity, and no heat generation. We can then integrate twice to determine and use our boundary conditions in order to determine the value of our constants. Plugging in, we can then get the temperature profile, which we can then use to determine the heat flux, as shown in the calculation below. For 2-102, we can also use a simplified version, as shown here. We can then integrate again, and integrate for a second time in order to determine the temperature profile. We can then use our boundary conditions, as shown on the previous page and here, to determine the temperature profile, and then solve for the temperature, which would be 125 degrees Celsius. In 14-40, we will be using the resources of table A9 and 14-6, and the relationship that Y vapor is equal to P vapor over P. This will allow us to get the answer to A. In addition, we use Henry's law, which is seen in the bottom left, to solve for the dry air and liquid composition, which is small, which is what we would expect in the situation given. Henry's law was also solved by using interpolation from table 14-6. Some remaining points of confusion this week are how to apply boundary conditions. This is a long, extraneous process, and I believe I need to work a little bit more understanding how to use it. The application of the boundary conditions and when they can be used is also a little bit difficult for me. Therefore, I think I need to apply them more and learn how to work with them. But being able to use them in the different coordinate systems is something that's very critical and something that I still need to work on. Thank you.